Magnetars. One of the most dangerous objects in the entire universe. But why are they so dangerous? What makes them so feared? To understand magnetars, we need to know about some properties of a neutron star. Neutron stars have magnetic fields. Now, neutron stars get their name from neutrons, which basically means that the entire star is mostly made up of neutrons. But wait, don't magnetic fields require charged particles? And aren't neutrons neutral? Well, yes. But there are a few protons left out. But neutron stars are extremely dense and physics gets a little complicated. Despite the name, neutron stars do have magnetic fields. But some neutron stars have even stronger magnetic fields. Their magnetic fields are 1,000 times stronger than regular neutron stars. These stars are known as magnetars. For comparison, let's take Earth's surface magnetic field, which is around 0.5 Gauss, and our Sun's magnetic field, which is just around twice of Earth's. That's around 1 Gauss. Now a neutron star's magnetic field is 1 trillion Gauss. Just imagine, if a neutron star alone can have a field of 1 trillion Gauss. Then what about magnetars? Magnetars can have magnetic fields of 1 quadrillion Gauss. That's 1,000 times greater than a neutron star. In other words, basically insane. But how does a magnetar have so much magnetic field, if it was formed from just a typical neutron star? One possibility is that they form from the merger of two stars. When two stars merge, they can produce a larger star with an extremely strong magnetic field. These are known as blue stragglers. When the blue straggler eventually dies and collapses, it could produce a magnetar. About 10% of neutron stars are magnetars. This makes them one of the most dangerous objects. Those fields are strong enough to wreak havoc on their local environments. What happens when you get too close to it? Within about 1,000 kilometers of a magnetar, the magnetic field is so strong that it messes with the electrons in your atoms. You would literally be torn apart at an atomic level. Even the atoms themselves are deformed into rod-like shapes. So, if we ever reach interstellar travel, let's hope we don't bump into one. One interesting thing about magnetars is that they can have starquakes, much similar to that of earthquakes. The crust of neutrons can crack, like the tectonic plates on Earth. As this happens, the magnetar releases a blast of radiation that we can see clear across the Milky Way. The most powerful starquake ever recorded came from a magnetar called SGR 180620, located about 50,000 light-years away. In a tenth of a second, one of these starquakes released more energy than the Sun gives off in 100,000 years. NBSP, like all dangerous things, magnetars don't last very long. And after 10,000 years, give or take, they settle down back to neutron stars. Still extremely dense and highly magnetic, but not like before. Thanks for watching. Be sure to check out our other videos. If you find this video useful, then leave a like and subscribe. Until then, Universe Elucidated.